Hey everyone. In today's demo, I'm going to be covering the Azure AI's Custom Vision platform. What this allows you to do is upload a couple images, click a couple buttons, and play with computer vision. So if you are not overly code savvy, you're still able to play with computer vision and get an idea of what's possible. So the first thing that you're going to want to do is create a new project. And when you click on the create new project, you'll give it a name and then you'll have an Azure resource. So this is just linking out to my Azure AI service. The next thing that you can do is select the project type. So you have this concept of classification and classification types. So if you pick a classification, you'll have a classification type. And the difference here is a multi-class classification. You have a single tag per image. So this image is a cat, this image is a dog. If you do a multi-label classification, it would say this image contains a cat, this image contains a dog. And then you also have the concept of object detection. So the object detection project type is just going to be able to detect individual objects within there. So it may show that there is a cat in the picture and draw a bounding box around it, or give you the bounding box around it. And oh, there's a dog in there as well. It'll give you the bounding box for the dog or where it's at as well. So those are the two different types of projects that you can build with this and some of the things that are capable. And then the domains, that's just going to kind of help guide the model as far as how it's going to do the training on some of these things. So, if you're going to be more specific to products on the shelf, you may want to select the product on the shelf as opposed to just a general one. I already have a couple projects spun up, so let's get going with the classification here. So for classification, you can see that I already have uploaded a few images, but let's add another image here. We'll add another car. And when I go to upload this image, it's going to ask for me to tag it. So I've already tagged some bikes and cars. It gives me the ability to tag a car. I upload that file and we're good to go. When I did upload it, it may have fallen into the untagged version. So if you're not seeing your image up there, make sure you check the toggles over here. So because it's tagged as a car, it's in the tagged bucket. All right, so I've tagged cars and bikes. The next thing that you can do is click train. And we'll just do a quick training for right now. All right, so the training's done. What do we do next? The next thing that we can do is publish this trained version. That way our API endpoints are able to actually use it. All right, so now that's been published. So the next thing we can do is come over here to the quick test and let's upload an image that it hasn't been trained on yet and see what it does. The prediction is a bike with 99% probability. So it predicted a bike pretty well. And you're able to come over here and look at the predictions that have been made by the model so that you can kind of adjust your model if you need to. But now this is allowing anyone without technical experience to be able to come in here and play around with computer vision. There will be a little bit of a demo afterwards of how to hit this with code, but we'll head over to the object detection now. Next, we'll look at object detection. You're going to need at least 15 images of the individual tags. So I've already added an image. It's in the untagged version here. So what we can do is click on that untagged image, hover over the items that we want to classify or detect or train on. So here we'll select the balloons and the soccer ball, and I can just go and close it. I now have no more untagged versions. So here we have 15 balloons tagged, 15 soccer balls tagged. The next thing we can do is look at performance. And here we can kind of set our threshold. So what's the minimum probability of them detecting an object, whether it should be successful or not. So if you need it to be highly accurate in the yeses, but it's okay if you miss some, well, bump that bad boy up to a higher threshold. That way you're always gonna have a more accurate result, but you might miss some. And the overlap is just for the bounding boxes to detect whether the prediction versus the correct one is right. And again, so as you bump that up, it'll get a tighter percentage, lower makes it a little more loose. And then what we can do here is click train, and we'll just do a quick training. All right, so the training is done on the object detection. The next thing we can do is run a quick test. All right, so we uploaded an image that it hadn't been trained on, and it found a couple interesting things. It found one balloon at 99%, which is, yeah, that seems right. Found another one that is thinking is about 25% right, which is interesting. I mean, it has the balloon in it, but it's also grabbing some birds or something. And then a soccer ball with a 25%. So with a mere 15 images of, pretty standard balloons and soccer balls, it didn't do too bad for not really being tweaked. And this is where you have the opportunity to now come in here and look at your predictions and adjust accordingly. So here we can see it found a couple balloons and whatnot, and be able to adjust your model, maybe upload more balloons, upload different types of soccer balls, so that it has a better understanding of what's happening. Not being tech savvy, I was able to upload a couple of images, click the train button, click the quick test, and I'm playing with computer vision. So now we'll jump into the demo part of being able to call these endpoints in code, just so you can kind of see how you might be able to do this programmatically. All right, for the coding portion, we're going to classify and detect an image. Once you've published your model, you'll need a couple things. So you'll have a published as iteration or iteration 1, iteration 2. I think you can name those as well. And then you'll also need your project ID, which happens to just be in the URL. You'll need your Azure AI Services and prediction key to get authenticated, and we're going to use the Custom Vision prediction client. And that's going to come from the Azure Cognitive Services Vision Custom Vision model. So the first one we're going to run is to classify. And this is going to need a project ID, which will come from the URL, published iteration name. So again, this was the iteration 2. Here we're going to have it classify a little yellow car. So if we take a look at the car, we'll see how it classifies it. Here we can see that it classified it as a 97% accuracy of it being a car and 2% of it possibly being a bike. So overall, pretty good when it comes to classifications, especially when I only uploaded 5 of each video or image. The next thing that we'll do is do a detect. So again, we'll need that project ID, the iteration name, and here we're gonna have it do a detect on an image of a soccer ball and a dude kicking it. We'll see how that pans out. And then what we're going to do is we'll just call the object or the detect image. We're going to then load that image, draw the predictions on the image, and then we'll also draw the names of the predictions and the percentages with them. And if we run that, this one came back quite surprising to me. It found a soccer ball with a 99% accuracy. It also found a couple other soccer balls within the soccer ball. I think what happened here was if we were to go back to this overlap threshold, I think that's where you might need to adjust that. I think what's happening is it's finding some of this images and repeating it. Some of these other ones are quite obscure. I don't know why it's thinking there's a balloon over here. Maybe because of the color in the arch aspect of stuff. Gives you an idea of how computer vision kind of works. It's not going to be perfect out of the gate, especially when you're only uploading 15 images. So yeah, I think that was a fun little exercise. Let me know if you have any questions below. Thanks.